seeing the default connectivity that we know we have in our virtual networks. For example, in the virtual networks, we know that intranetwork traffic and outbound internet traffic is allowed by default. But by default, our virtual networks are isolated. And what this means is that they are isolated from other virtual networks that are in the Azure cloud. And this is for good reason, of course, to protect our networks so that we can all have our own individual isolated networks whenever we want to. But in the instance in which we have multiple virtual networks and we want to connect them, well, this is where VNet peering comes in. It allows us to bridge together our virtual networks so that we have connectivity between these networks using a peering connection that we set up for our virtual networks. Now, something important to know with VNet peerings is that they're non-reciprocal, and what this means is that the connection has to be established on both sides in both directions, right? So what we have to have is a peering connection for VNet 1 to talk to VNet 2, and a peering connection going in the other direction allowing VNet 2 to talk to VNet 1. Now, we can make these peering connections between virtual networks inside of the same regions in the Azure cloud. And we can also make peering connections between regions across the Azure cloud globally. So we could have several different regions connected using virtual network peering connections. And another thing that we have to keep in mind with VNet peerings is that they are non-transitive. And what I mean by regions connected using virtual network peering connections. And another thing that we have to keep in mind with VNet peerings is that they are non-transitive. And what I mean by here is that say we have a peering connection between VNet 1 and VNet 2 and the one going in the opposite direction to VNet 2 to VNet 1. These virtual networks are peered. And then let's say that VNet 2 is also in a peering relationship with VNet 3 here. And this peering connection allows VNet 2 and VNet 3 to communicate. Well, just because VNet 2 is able to communicate with VNet 1 and VNet 3 does not mean that VNet 1 and VNet 3 can communicate. Because, again, virtual network peerings are non-transitive. We'd have to create a separate peering connection between VNet 1 and VNet 3, and we'd have to have that peering connection in order for them to communicate going in both directions. Now, we're going to see this in action in our demonstration whenever we have this exact same setup with 3 different VNets, with 3 virtual machines spread across each of these VNets, and we're going to see how when we create virtual network peering connections between these VNets, that we're able to communicate from virtual machine to virtual machine in other networks because of these VNet peerings. And we'll also see that we have non-transitive connections in which we can't have VNets communicate like VNet 1 and VNet 3. Now, some important benefits that we have to understand about VNet peering is first that it's going to provide us low latency, high bandwidth connections because this traffic is going to traverse the Microsoft backbone for us, allowing our virtual networks to communicate. And this cross-network communication that we're going to have is going to allow us to, as long as we don't have overlapping CIDRs in our networks, have communication and connectivity between the virtual networks so that we can have multiple networks inside of the Azure cloud. And we can have data transfer between and across both subscriptions, AAD tenants via Azure roles, and Azure regions with our cross-region VNet peerings. Alright, Guru, so at this point in our lesson, we're going to make our way into the Azure Cloud Sandbox and get started with our demonstration of implementing VNet peering for ourselves. So let's make our way to the portal. Alright, Gurus, here we are in the Azure Cloud Sandbox, and to show you what I've got already set up for this demonstration here, of course I have the storage account configured with my Cloud Shell, and then I also have 3 virtual networks here, 2 of which, VNet 1 and VNet 2, are inside of the same region, and my 3rd VNet, which is inside of a different region that we can use for global VNet peering. Now, I just want to show you that each of these has a different IP CIDR. My VNet 1 here has a CIDR of 10.0.0.0/16, and my VNet 2 here has a different CIDR of 192.168.0.0/16, and of course my VNet 3 also has a different CIDR here. And what I'm showing you here is that the IP CIDRs for each of our virtual networks needs to be different. We can't have overlapping IP CIDRs here, otherwise we won't be able to make those peering connections. Now, I have inside of each of these virtual networks a virtual machine, and these virtual machines cannot communicate because these virtual networks are isolated from one another. And by using VNet peering, we're going to be able to allow these virtual machines to communicate. I'm going to go into virtual machine 1 here real fast. I'm going to grab its public IP address. Then I'm going to come up to the Cloud Shell here, and I'm going to SSH with my username into the public IP, and then I make that SSH connection into my virtual machine here. I'm going to clear up and run the host name tac I command to get the private IP. And what I'm going to try and do is I'm going to try and ping with a 3 count another virtual machine in my virtual network 2. And if we remember, my virtual network 2 is 192.168 network. And it's going to be a .0.4 for that virtual machine because it's the only VM inside of that virtual network. Hit enter, and it's not going to be able to reach it. And that's because we don't have a peering connection set up for this virtual network. And that's what we're going to be doing here. So if we minimize the Cloud Shell real fast, go back to our resource group, and go down to VNet 1, and come down to the settings and select peerings. This is where we can add our virtual network peerings. We'll click add here, and now we're going to set up the peerings for these virtual networks. We're going to create a link on both sides, and we can do this all in the same place. We're going to call this first link here VNet 1 to VNet 2, and then we have our options here to allow traffic to the remote virtual network from this virtual network, so VNet 1 to VNet 2, and then the choice to allow the traffic forwarded from remote virtual network, so VNet 2 to VNet 1. And we're going to leave those as they are selected by default, and then we'll come down and we're going to name this second peering link here. We're going to call this the VNet 2 to VNet 1, and this is going to have the same options here. We'll select the virtual network VNet 2, and we have the same options of choosing to allow traffic to the remote virtual network, so in this case VNet 2 to VNet 1, and then again the traffic forwarded from the remote virtual network, so VNet 1 to VNet 2. We'll leave all of those as they are selected by default. We'll click add here, and we see it's going to add the virtual network peering on both ends so that we have the link on both sides so that we can communicate with these virtual networks. Now this is going to take a couple minutes to finish, so we'll be back when it's done. Alright Gurus, so we're back, and as we see here, under our peerings, we have our peering connection, and the status is connected. And what we'll notice if we go back to our resource group, and go into VNet 2, and then go down to settings and peerings, we'll see we have that VNet 2 to VNet 1 connection, so it created it on both sides. Now if we come back up to the Cloud Shell here, and I clear up, and choose to run that same ping command by running ping with a 3 count for the VM's private IP that's in VNet 2 from VNet 1, and we see what's going to happen is now I can connect to that other virtual machine. I've peered these networks and they don't have overlapping CIDRs, so I'm able to communicate. Now with our example here where we have a third virtual network, we could expect the same kind of behavior, right? If we create a peering connection between VNet 2 and VNet 3, well then they'll be able to communicate. And because of peering connections being non-transitive, that doesn't mean that VNet 1 can talk to VNet 3 just because VNet 2 is connected to both of them. That traffic can't flow through VNet 2. Instead, we need that third peering connection between VNet 1 and VNet 3. So let's go and create that connection here. And we'll go over to our VNet 3 here. And what we're going to do is test it out. We're going to create a peering connection from VNet 2 to VNet 3. We're going to call this one VNet 3 to VNet 2. because I'm creating this on VNet 3. We'll leave everything selected as it is by default, and then we'll call the other link VNet 2 to VNet 3. And then we're going to select our virtual network 2 here because we're inside of virtual network 3. We'll leave all the options as they are by default. Click add, and it's going to add that third virtual network. So we'll be back once this is finished to test that communication. Alright, Gurus, so we're back, and that peering connection has finished provisioning. Now we don't need to test this. This is going to be a cross region because VNet 2 is in one region and VNet 3 is in another region. This is going to be a cross region peering connection, and we know this is going to work the same way as we worked in the other peering connection that we had between VNet 1 and VNet 2. What we want to test here, while we're inside of VNet 1, is can I ping a VNet 3 VM? And I'm going to test that by running a 3 count ping here for 172.16.0.4 because it's the private IP of the VM3 inside of my VNet 3. And we see that this communication is not happening, and that's because of non-transitive peering like we were talking about. We'd have to create a third peering connection between VNet 1 and VNet 3 in order for this to work. Alright, Gurus, that's everything for this demonstration. We successfully configured virtual network peering between cross-region and same-region peerings and showed the non-transitive property of peering connections between virtual networks. Let's head back to our slides for a quick review of this lesson. Alright, congratulations, Guru, if you followed along with the demonstration where we configured VNet peerings for same-region and cross-region between 3 virtual networks. Now, if you need to refer to the previous lessons on creating virtual networks in order to help set yourself up for this demo scenario in this lesson, please make sure to refer to those lessons because the course is thematic on building up your skills as we go through each technology. Now, the key takeaways here from this lesson, configuring Azure VNet peering, are that we have 2 types of peerings. We have virtual network peerings and global virtual network peerings, where we can do things like same region and cross region network peers between virtual networks that we have in the Azure cloud like we saw in our demonstration. Now, the benefits that we get with VNet peering are low latency, high bandwidth connections that allow for cross-network communications like we saw between our virtual machines in our peering connections. And this allows for things like data transfer between subscriptions, AAD tenants via Azure roles, and Azure regions. Another thing that we need to keep in mind, like we saw, is the transitive property of VNet peering. Peering connections are not transitive. And so that means that we couldn't traverse traffic from VNet 3 to VNet 2 to VNet 1. We have to have a separate peering connection between VNet 3 and VNet 1 in order for them to communicate. And then we also have to keep in mind reciprocity here. Peering connections are not reciprocal, and we need a peering connection. That's everything for this lesson. Hey, and welcome, Gurus, to this lesson implementing VPNs, where we're going to start off by comparing VPN gateways to VNet peering so that we understand the times in which we would choose VPN gateways over VNet peering, and then we're going to talk about the capabilities for hybrid networking that we get with our VPN gateways. We're going to talk about the routing types that we have with our VPN gateways and the VPN gateway SKUs and their capabilities. And then we're going to talk about active versus active passive configurations for those VPN gateways, and then we're going to go through a demonstration of implementing a VPN gateway inside of the Azure Cloud Sandbox. So let's get started. In Azure, a VPN gateway has the same purpose as a peering connection using VNet peering. What we want to do is we want to make hybrid networks by allowing networks to communicate in the same way that we do with virtual network peering inside of our VNets, except for with our VPN gateways, we can do this specifically with our on-premise environments rather. And the components of a VPN gateway are going to allow us to connect 2 different networks, both our Azure network, our virtual network, and our on-prem network or another virtual network over the public internet using various components like a virtual network gateway to establish this VPN gateway, a gateway subnet that is required in the virtual network, and each of these virtual network gateways are going to have a public IP because, again, this is going to be over the internet communications using an IPsec tunnel for encrypted communication. So if for whatever reason this traffic is captured, it is encrypted, so it's going to be difficult for anyone to exploit that encrypted traffic that they captured. Now, with that being said, you're probably asking, why would we select a VPN gateway over virtual network peering? Well, the reason is going to be the capabilities that Azure VPN Gateway provides us in establishing these point-to-site VPN gateways and site-to-site VPN gateways with their on-premise networks. And those are features that we don't get with the VNet peering connections that we have, where we're just peering to virtual networks in the Azure cloud. If we want to have a way for our remote users to connect to our networks in the Azure cloud and a way to connect our on-premise networks to our Azure virtual networks. Now, one of the things that makes VPN gateways in Azure different than VNet peerings is that with our VPN gateways, what we have is transitive traffic. And what I mean by this is that, say we have a VNet peering connection with two different VNets, like we see here in this diagram. Well, as long as we have a way of using the gateway transit in the settings of the peering connection itself, what we'll be able to do is communicate with the on-premise network from that virtual network as well, because of that transitive property of allowing that transitive traffic. And again, we just have to have that enabled on that peering connection. So in cases in which we want to have encrypted traffic, or we want to have transitive routing inside of our networks, then what we want to use is a VPN gateway. Now, this brings us into talking about the routing types that we have. We have policy-based routing, which allows static routing via policy declarations that we make. And this means that inside of networks where things are constantly changing, we have to statically update these routes. Now, with policy-based, we also have support for on-prem legacy VPN devices. We only have support for IPv1 encryption, and we can only use the basic SKU of our VPN gateway. Now, with route-based routing type, what we have here is static or dynamic routing. So in the case of which we have an environment that's constantly changing, we might use the route-based dynamic routing because it's resilient to topology changes in an ever-evolving network. Now, with route-based, what we have is the ability for coexistence with express route, which is something we'll cover in a later lesson, but this allows us to have a direct connection using express route coexist with our VPN gateway. And then with route-based, we have support for IPv2, a newer version of encryption. Now, with our VPN gateways, we have a few different SKUs here. We have basic, and this allows max 10 site-to-site tunnels. We have the throughput of 100 megabits per second for our basic here. And then for our VPN gateway 1AZ, what we have here is a max of 30, and we have 30 for the rest. But the key differences here are 650. We have one gateway should only be used in depth gateway to get to. With our VPN gateways that we is not supported. Now let's shift gears here at this point and talk about something known as active, and active passive. With our VPN gateways that we create, right, what we have the option of using is either the active or active passive configuration. So say we have a VNet gateway here, and we're having a VPN connection between an on-premise network. Well, what is going to happen here in a traditional method in which we don't configure active is we have active passive. And what this means is that our IPsec tunnel is going to be existing between a VNet gateway that is active and the active local network gateway on-prem. Now, what we're going to have here is a standby VNet gateway that is going to allow connection to a standby local network gateway. And that way, what we can do is, should our VPN gateway fail, well, we have that second VNet gateway resource to take on the traffic. And in the active configuration, both of these are running as active and neither of them are a standby. Now, at this point in our lesson, we're ready to talk about our demonstration. What we're going to be work. Now, this is going to represent our Azure site network. And what we're going to have is a HQ make sure that between these virtual machines, we'll verify that both of these networks can communicate, and we'll verify that with the ability to communicate between these virtual machines. Now, what we need to do in order to set up a VPN gateway is, of course, create our gateway as well. Azure work with the active and the active local network gateway on-prem. Now, what we're going to have here is going to represent our Azure .u, our on-prem network, and it's communicate machines. What we need to do in order to gateway subnet, we have to specifically call it our gateway subnet to use the /27 prefix, because this is what Azure recommends for us to use so that we have the proper amount of IP addresses for scaling traffic when we're using our VPN gateway. And then next we'll create our HQ local network gateway. And again, remember, we're doing this inside of Azure and having a H gateway used, and then create our Azure side virtual network gateway. And then we can create a connection inside of that virtual network since we have in our HQ local network gateway. And then we're going to do the same thing in the other network. We'll have a gateway subnet inside of the HQ VNet with the /27 prefix. And we're having to do this again, remember, because the HQ VNet is representing our on-prem virtual network, and in the case of the sandbox, HQ side virtual network gateway, and make our. Now, due to the duration of this lesson, we're going to be splitting the demonstration into a second lesson following this one. So we'll pick up in part 2 of this lesson. Hey, and welcome back, gurus, to the part 2 of the Implementing VPNs lesson, where we're going to be going through the demonstration portion inside of Azure. So let's make our way into Azure and get started. Here we are, gurus, in the Azure Cloud Sandbox, and we have exactly what we talked about, except for the setup of the virtual network gateway. We have our virtual network that is our Azure network, our virtual network that represents our on-prem. HQ, and inside each of these we have a default subnet, and we have a virtual machine inside of each of those subnets. We have an Azure VM, and then we have our HQ VM. Now, what we want to do is be able to connect from the Azure side network to the HQ network, and we're going to go into our VM1 here and copy. the public IP, and I'm going to make an SSH connection into this Ubuntu virtual machine here using that public IP, and now I'm inside of the Azure network. Let's go ahead and clear up our display here, and I'll run the host name tac-i command, and we'll see that I have the private IP address for this VM1 of 10.0.0.4. My other virtual machine has the private IP of 172.16.0.4. So if I try and ping it with a 3 count, I shouldn't be able to communicate with it, just to prove to you that they're not connected using some sort of pairing or VPN gateway. Then this is going to fail because we don't have a connection set up between these two networks. And that's what we aim to do with our VPN gateway here. So we'll minimize our Cloud Shell, come up to the search bar here, and we're going to type in virtual network gateways and select it under services. We'll click create here, minimize this portion of the blade, and we'll begin configuring this virtual network gateway. I'm going to call this my Azure-VNG, and I need to make sure to use the region where the rest of my resources are, like my virtual network, so that I can use that virtual network, and mine is in West US. And then I'm going to make sure that my gateway type is VPN, because we're not using ExpressRoute. We'll talk about that in a later lesson. Then my VPN type is going to be route-based, so that I have that dynamic routing in case my environment changes, like getting more virtual machines. I'm going to leave the SKU options as they are by default and select my virtual network. I'm going to pick my virtual network for Azure. And then we don't have a gateway subnet inside of this virtual network, so we can actually create one while we're creating this virtual network gateway. Now we're going to give it that /27 prefix as suggested by Azure, and then we're going to move down to creating our public IP address. I'm going to call this my Azure VNG pip, and we're going to let it create that, and we're not going to be enabling active or configuring BGP. We'll just click review and create here, and then it'll validate. We'll click create, and it's going to go off and create our virtual network gateway and give us a public IP address for it. Now this is going to take about 45 minutes to happen, so I'm going to behind the scenes create the other virtual network gateway for the other virtual network that represents our HQ virtual network, and we'll be back once these finish provisioning. Alright gurus, so we're back, and both of our virtual network gateways are finished provisioning. We have our Azure virtual network gateway and our HQ virtual networks. But in creating our local network gateways, we're going to need the public IP addresses. So I'm going to go into my Azure virtual network gateway. I'm going to click on the public IP address. I'm going to copy the IP address, and I'm going to head back into my resource group. And now I'm going to come up to the search bar, and I'm going to type in local network gateways and select it under services. Then I'm going to click create. I'm going to minimize this portion of the blade, and now I'm going to create this local network to create. I'm going to minimize this portion of the blade, and now I'm going to create this local network gateway, and I'm going to specify my case. I'll click create and the IP address space of the HQ virtual network. So I'll do that in the background, and we'll be back once both of those are done provisioning. Alright gurus, so we're back, and we have both of our local network gateways for the Azure and HQ side finished provisioning, and now what we need to do is create a connection between these local network gateways and our virtual network gateways. So I'll come into the Azure virtual network gateway, and under settings I'll go to connections, I'll click add, and here I'm going to add my connection. I'm going to call this connection Azure to HQ, because it's going to connect my Azure virtual network base lesson. Here we have our Azure virtual sides. So I'll put a gateway here, and then I'm going to create a connection going in the opposite direction with the same configurations going to the opposite side's local network gateway. If I open up the Cloud Shell here, I should now be able to make this ping config go through without issue, no packets lost. So we've successfully created our virtual network and our subnets inside of that virtual network that we want to have a gateway. Now this VPN gateway we get with our virtual network gateway will allow us to communicate, and it's going to be inside the connection that once we've done that, we can then create the then I'm going to click create, I'm going to minimize this portion of the blade, and I'm going to call this the address of the Azure Virtual Network. I'm going to leave everything else it is, the configuration, the Azure Virtual Network gateway. I'm going to call this the Azure LNG. And then what I'm going to do is give it the public IP address of the Azure Virtual Network Gateway. And then I'm going to specify the configuration details for the address space, in my case, and our virtual network gateways. So I'll come into the Azure Virtual Network Gateway, and under settings, I'll go to connections, I'll click add, and here I'm going to add my connection. I'm going to call now, and as we see, this will another virtual network. And we could do this. Right, the side here we have our use a shared key. I'll put in that key to enable BGP protocol because I'm going to create this connection, and I'm going to go into the other virtual network gateway, my HQ virtual network gateway here, and then I'm going to create a connection going in the opposite direction with the same configurations in the background. So we'll be back once that's done. Alright gurus, so we're back, and I've created both of the connection gateway. If I open up the Cloud Shell, going to the opposite side's local network gateway, if I open up the Cloud Shell here, I should now be able to make this. Alright, we then create our gateway, and then a secondary virtual network gateway and another virtual network, or we can create a site-to-site connection like we did in our demonstration, and we can also create point-to-site connections inside of our virtual network gateways for our remote user device. And all of this. Look forward to seeing you in the next lesson. Hey, and welcome gurus to this lesson, Configuring ExpressRoute, where we're going to begin by describing what ExpressRoute is as we talk through reasons why we want to use ExpressRoute, and then we're going to talk about the implementation steps that go into setting up ExpressRoute, and then we're going to go into the Azure Cloud Sandbox to emulate as much as we can of actually setting up an ExpressRoute. So let's get started. ExpressRoute is the service that we utilize in the Azure Cloud to make a direct physical connection connection into our Azure resources and Microsoft resources. Now, how this is different from a VPN gateway is it's not a IPsec tunnel connection, right? What we're making is a physical dedicated connection. And this connection is not encrypted by default, but it allows us to make that private connection physically over the wire to the Azure cloud and our Microsoft resources from our on-prem networks. And what we're talking about here is our Azure cloud resources, like our infrastructure as a service resources like virtual networks and virtual machines. And we're also talking about our Microsoft resources like Office 365, and this includes things like SharePoint Online or Exchange Online, but also our PaaS services that we have inside of Azure. And this is inclusive of PaaS services if they don't have a private endpoint inside of our virtual networks. They could easily end up on either side of the Microsoft or Azure side of this connection. And we're trying to connect our on-prem network to either these Azure resources or Microsoft resources. And we can do this using what are known as edge locations. On the Microsoft side of things, we have the Microsoft edge location, and on our side of things, we have a partner edge location. We can utilize a partner like an ISP to allow us to connect from our on-premise networks to that ISP that then has a physical connection from the partner edge to the Microsoft edge. And this is what we're talking about with ExpressRoute. We create ExpressRoute circuits, right? We have both a primary and a secondary circuit that exists between the Microsoft edge and the partner edge, allowing for a highly available connection on two physically dedicated connections into the Azure resources and Microsoft resources that we have. And then we connect through our partner to our on-premise network, allowing us to connect from our on-prem network to the partner edge, from the partner edge over the ExpressRoute circuits, primary and secondary, to the Microsoft edge, and thus into our Azure resources and Microsoft resources. Now, when we're connecting into these resources, what we have are peering configurations. And after we've created our ExpressRoute circuits, the peering configurations that we have once we have successfully provisioned the partner edge side connection to our on-prem network is the Microsoft peering, and this is going to be a peering that allows a connection to our resources like Office 365 and our PaaS services. And then for our Azure resources like our virtual networks, our virtual machines, and our private endpoints, we use a peering configuration of Azure private peering to connect to these things through our ExpressRoute. Now, whenever we're doing this, what we have to keep in mind is that we have to have a virtual network gateway for our private peering connection into Azure to connect to our virtual networks. And then we have to create a connection on our ExpressRoute to connect to this virtual network gateway inside of our virtual network. And of course, the virtual network gateway needs a gateway subnet, much like we've seen in setting up a VPN gateway using the Azure virtual network gateways and making those connections, but rather we're connecting the ExpressRoute to the virtual network gateway in this case. And then whenever we're setting up our ExpressRoutes on-prem, what we have to have is an ASN number, the autonomous system number that we're going to use in the ExpressRoute configuration. And then we have to have a VLAN ID, and this is going to represent the VLAN that we're using to peer our network. And then inside of our network, we have to create 2/30 subnets. And each of these subnets is going to have 4 addresses, and 2 are going to be in use. And then the other 2 are going to be what we're using to maintain our connection via ExpressRoute and to have a BGP session to exchange those routes. the express route. And then we're going to have a shared key, much like we have with our Azure VPN gateways when setting those up for Azure. And then we are going to, in the case of a Microsoft physical, go into creating express route circuit. And what we're going to get back is a service provider key that we're going to give to the provider that we've selected for our express route so that they can help us get set up for our express route from the partner edge to the Microsoft edge. And once that has successfully been provisioned and connected, we can set up our peering configurations, determining on whether or not we want that Azure private peering or that Microsoft peering as we cover. And then we're going to create that connection from our express route to the virtual network gateway, providing us that private peering. Now at this point in our lesson, we're going to make our way into the Azure Cloud Sandbox, and we're going to go through accounts that are the configurations, this public IP address. Now what we have here is our virtual network inside of the Azure Cloud to represent what it is that we would be making our Azure private peering connection to. And what you have to just simulate in your head is that we have our on-premise environment that we're trying to make a point-to-point connection with using ExpressRoute. And that's exactly what we're going to try and walk through as much as we can inside of the Azure Cloud Sandbox. So we'll come up to the search bar, and first we're going to create our ExpressRoute by typing in ExpressRoute, and we're going to select ExpressRoute Circuits under Services rather than ExpressRoute Direct, because that is a separate variation of the service that provides a direct connection into Microsoft rather than going through a provider. Now we'll select ExpressRoute Circuits, we'll click Create here, and we'll minimize this tab, and then we're going to select our resource group, and then I'm going to specify my region. I'm going to select South Central US like my other resources, and then I'm going to name this my XR-01, and then I'm going to click Next into Configuration. And here in our configuration options, we see we have to select our port type. What we can do is select, and we're going to create new in this case, and we have our options to select from multiple different ISP locations to see the locations that are available. We have Silicon Valley and Washington, D.C. We'll select Silicon Valley here as an example, and then next we'll select our bandwidth options. We have the option between 50 megabits per second or 10 gigabits per second. So we'll have to determine what our needs are as far as bandwidth. Let's say we need high bandwidth here. We'll go with our 10 gigabits per second. And then we have to select our SKU here. Now we have local, standard, and premium, and what local is going to provide us is access to make a connection between our on-prem environment and 1 to 2 Azure regions in this same metro area as our circuit resource. For example, East US, East US 2. And then standard is going to give us access to all of the Azure regions inside a larger geography like the United States or Europe. And then the premium is going to provide support for more than 4,000 routes, the ability to connect to more than 10 virtual networks, and it's going to give us that global connectivity so that we don't have to worry about those geography boundaries like the United States and Europe. We'll be able to connect all across the globe. And Premium is also going to give us that access to services that are deployed worldwide. Now, for our example, we'll just run with standard here. We're going to see inside of the Azure Cloud Sandbox is we don't have the permissions to be able to finish this, but if we were to finish this, it would create our resource, and then we'd see in its settings where we can create our peerings, and we'd see our service key that we're going to give to our providers so that they can create our primary and secondary connections from the partner edge to the Microsoft edge. And once all of that is done, and once we've created our peering configurations for either Azure Private Peering or Microsoft Peering, depending on our use case, then what we're going to do is we'll come up to the search bar and we're going to create a virtual network gateway by selecting it under services, and we'll create this virtual network gateway inside of our virtual network that we're trying to create the peering connection with. And once we've done that, then we go into the peering sandbox, let point-to-point connection using that Microsoft Edge and that partner edge, or additionally a direct connection into Microsoft's global network from our on-prem network, depending on what expressed via that party, so that those needed physical, and you just have to understand what I will have to do rather than going through a provider. Hey, and welcome, gurus, to this lesson, implementing virtual WAN, where we're going to be describing what virtual WAN is by talking. Let's get started. With networks, where we do things like have our VPN connections to create this firewall, all through that represents for organizations that have peering support. And with our basic SKU, we only get site-to-site VPN connection for our remote users, express route connections, and VNet to VNet connections for our Azure WAN. So we get a lot more connectivity, and if we're going to use anything for production, Azure Clouds, we have a that's AN2 base for connecting our VNets, express route services here. We'll click create, specify our one site-to-site. Alright, gurus, so we're back, our functions as well as the transitive peering. So we'll click review and create here, and then we're going to click create our fully meshed network. And what we can do is manage things like our hubs, which our hubs are going to be managed these staying here, and then I'm going to click. Alright, gurus, so we're back, and our virtual hub has finished deploying for our virtual WAN. We'll go ahead and click review and create. It'll validate, and we'll click create, and it's for site-to-site, point-to-site, and express route. We can enable the gateway now, or we can do it after the hub creation here. We see that we can just enable the gateways for each of these depending on whether or not we want a site-to-site, point-to-site click into our WAN. What we'll see is if we click on hubs, we have a region where we manage things like to manage that we have existing inside of the Azure cloud into this fully meshed network. So we really have just a single operational interface to connect all of our virtual networks, to connect our express routes, our VPNs, both site routes for our fully meshed network here. Now again, what we get with our standard SKU is the transitive peering, and we also get all of these, the site-to-site, the point-to-site, the express route, and the virtual single ops with, and we manage it all through that single operational interface. Now we get different features with different virtual WAN SKUs. Our point-to-site WANs, managed routes that we have for virtual hubs. And again, these virtual hubs are managed virtual networks where we don't have to worry about setting up gateway subnets. All of that's going to be managed for us whenever these virtual hubs are managed virtual networks where we don't have to worry about setting up gateway subnets. All of that's going to be managed for us whenever we set up a virtual hub and configure it to use things like the site-to-site VPNs, the point-to-site VPNs, and express routes, all these gateways. I look forward to seeing you in the next. Hey, and welcome, gurus, to this video lesson, creating and managing